Hey guys, so this is lesson 5.4, function notation. Please open up to your notes section. If you did not finish the video today, part of your homework is to finish this video. It is on my YouTube channel, and you do have bookwork, so make sure you check the assignment board. Please pause the video when needed to copy down all of the notes for the section. Let's kind of start off here. Notation. So we've already been talking about functions this whole chapter. A function is, well, one, we like to refer to it as kind of related to an equation, but it has a special property that every input has exactly one output. Now there's going to be a new way to write it. So what we're used to seeing is, y equals something that maybe looks like mx plus b. The only thing that's now changing is that instead of talking about y, we're going to use this function f of x. So really we're working with f of x, and that's how you read this. This f, the parentheses, is kind of like the word of, so f of x. Now we're just going to have something just kind of replacing y. We're not going to talk about y anymore. We're going to talk about f of x. F is the function. This kind of just represents the equation. X is your input. That has not changed. F of x is the output that corresponds with the x. That just means it's the y value. So don't get too caught up. This is all stuff that you're used to seeing. It's just now we're going to call it something different. It doesn't always have to be f of x. It could also be g of x or h of x. It's not always f. F is just most common. Again, pause the video when needed to copy on all your notes. I'm going to move on to the example. Our first one is evaluating a function. So in example 1, we have the function f of x equals negative 4x plus 7. And we're trying to figure out what this all comes out to be if the x is 2. So what you do is you're substituting, you're plugging in this 2 anywhere you see an x. So you're really saying f of 2 equals, again, think of this like y equals, negative 4 times 2 plus 7. And then you're evaluating this like normal. So negative 4 times 2, a negative times a positive is negative. 4 times 2 is 8. And you have 8 plus 7. F of 2 here on the left side just kind of tags along. And if we just finish doing our subtraction here, we have f of 2 equals negative 8 plus 7. That's negative 1. So this says if my x value is 2, the output, or if you want to think about like a y, is negative 1. That is your answer. It looks more complicated than it is. Again, pause the video, raise your hand, say please pause the video at any point that you need it. B is yours, so you are evaluating the function f of x equals 3x minus 8 when x is negative 2. This is your example, so please pause the video, work on it, and then have the video unpause to check your work. Okay, so to check your work, we are substituting this x value of negative 2 anytime you see this x. So you really have f of negative 2 equals 3 times negative 2 minus 8. Again, you should have been evaluating it at like normal, so you'd have f of negative 2 equals a positive times a negative is a negative. 3 times 2 is 6, and we have 6 minus 8. Again, just doing some subtraction, f of negative 2 equals, now negative 6, take away more, is negative 14. That is your final answer. Hopefully you were working through that okay. We're going to move on to the next part. Again, pause the video if you need to get work copied down. Next part of our notes. We are going to solve for x, which means we're solving for the independent variable, when something's in function notation. So in our example here, we have h of x equals 2/3 x, or 2/3 times x, minus 5. And we're going to figure out what this x value is if this entire little expression, h of x, is negative 7. So again, if it helps you, think of h of x like y. So this is saying y is negative 7. And really we'd have the equation y equals 2/3 x minus 5. This is no different than a chapter 1 problem. You're substituting means you're plugging in the value of negative 7 for h of x, or the y if you'd like to think of it that way. So what you're doing is having negative 7 equal 2/3 x minus 5. And then you're solving for x. So you're undoing addition and subtraction first, so I'm going to move this minus 5 by adding it. This gives me 2/3 x equals negative 7 plus 5. Well, I have more negative than positive, so my answer is negative here, and this gives me a negative 2. Then from here, we have to undo the secret operation of multiplication. Remember, the trick is to multiply by the reciprocal, which means upside down fraction. So I'm going to multiply both sides by 3/2. You could do the other method, which is copy dot flip, because you'd have to divide by a fraction. Regardless, you get the same exact answer. So when I do my reciprocal, or my quick cancellation of fractions, I have x equals 3/2 times negative 2. I'm just going to make everything a fraction. So I'm going to put negative 2/1. From here, let's see if I can cross simplify or cross reduce 3 and 1. I can't simplify that more than it is. I can't divide anything out that's the same besides 1. Let's see about the 2's. Well, I have 2 and I have negative 2. Well, I can definitely cancel 2's. 2 divided by 2 is 1. 2 divided by negative 2 is negative 1. So I really am working with what's 3 times negative 1. Well, that's negative 3. 1 times 1, that's 1. And negative 3/1 is the same thing as just negative 3. So if my output, or my f of x, or my y, however you'd like to think of it, if my output is negative 7, then it forces my input, or the x, to be negative 3. It all comes down, in the end, to a chapter 1 problem. Make sure you're pausing the video, or letting the teacher know that you need to put video pause to copy down all of the work. B is yours, so please pause the video, work through this. You are working on g of x equals 3x minus 8, and you're finding the x value if the expression g of x is negative 5. So it means you're substituting or plugging in negative 5 for the entire g of x. Okay, please pause the video and work on this problem. Okay, let's check your work. So you should have plugged in negative 5. That gives you negative 5 equals 3x minus 8. Again, chapter 1 problem, undo addition and subtraction. So get rid of subtraction with addition. Let's add 8 to both sides. This gives me 3x on the right, and negative 5 plus 8, well, that's just positive 3. Getting x by itself, you're undoing the secret operation of multiplication with division, so divide both sides by 3. This gives me x equals 1. Again, this is saying if the output is negative 5, the input has to be 1, given our 3x minus 8 function. Okay, you're almost done, guys. Oh no, graphing. Don't worry, it's not that bad. You don't need graph paper, just do a rough sketch. This is a lot of writing here, I know, so you might need to pause the video to get this all written down. But to graph functions, well, when you're graphing a function in function notation, that means f of x, that's what function notation is, it is no different than graphing a linear line. So that's like graphing y equals mx plus b. It's the same thing. So what that means is if I have the function, say, just for example, f of x equals 2x plus 5, to graph this, I'm graphing it like I normally would, which means I'm graphing y equals 2x plus 5. So I'd start the y-intercept, use my slope to draw 2 other points, and connect it with a ruler. You guys do not need to pull out the rulers today. It really, oops, too far. It really will be fine. What will be new is talking about something called a vertical translation. Vertical means we're talking straight up and down. Translation is a fancy word for slide. It means I'm sliding up and down. And when we're talking about our sliding, we talk about how many units I either slid up from the origin, so our 0, 0, or how many units we slid down from our origin, which I spelled wrong. I'm missing an I in here. And it's our y-intercept that actually tells us how many units we're sliding up or down when compared, wow, I really struggled here, origin. In our official function notation, what this looks like is we'd have f of x, which is something. It could be 2x, it could be x, it could be negative x, but it's plus k. It could also be minus k, so let me add this in here. You could also have f of x minus k. This plus refers to if you have a positive y-intercept. The minus refers to you have a negative y-intercept. But we like to talk about translations when k is not 0. So this is saying k can't equal 0. Well, why can't k equal 0? If k equals 0, that would mean our y-intercept is at the origin. It's at 0, 0. So if I'm already at 0, 0, I can't talk about moving away from it. That's where I'm stuck. So we're not going to talk about if the y-intercept is ever 0. Okay, if you need to pause that and scroll back up, you can. Example 3. We are going to graph g of x equals x minus 3. And we're going to compare it to the graph of f of x equals x. So here off to the side, again, this just needs to be a rough sketch on your paper, so I just kind of went up by ones, and I went up to positive 4 on the y, negative 4 to the right 4, to the left 4. The functions that we're working with, or the equations, the graphs, if you want to think of it this way, f of x equals x. This is a fancy way to say I'm working with the equation y equals x plus 0. So my slope is 1, because there's a secret 1 right here. The y-intercept is 0. The other function we have to graph is g of x equals x minus 3. This just means you're graphing the equation y equals x minus 3, where you have a slope of 1, again there's a secret 1 here, and the y-intercept is negative 3. The comparison, and you'll see this on your homework, I just want you to tell me how many units, let me write it down here. You're really saying how many units is g of x, or how many units, let me go back, how many units up or down is g of x compared to f of x? That is what you're comparing. So in order to do that, at least to begin with, we're just going to graph the two equations. So f of x, I already graphed in purple. Again, y-intercept is 0, slope is 1, so rise 1, run 1, rise 1, 1, 1, and so on. I'm going to graph my g of x in pink. So my y-intercept is negative 3, so 1, 2, 3. I'm going to go down here. I'm going to stop. I'm going to draw this lovely point. My slope is 1, so you rise 1, run 1. Rise 1, 1, run 1. Let me do one below. So instead of rising, I'll do the opposite, which is falling. Instead of running right, I'll run left. And then don't pull out the rulers for just this one graph. It is not worth it. Just kind of use the edge of a piece of paper. But there you go. In pink is what I have is my g of x. Now I just want to know how many units is my pink line, shifted up or down compared to the purple line. Well, my pink line, or the g of x function, it's below it. Well, how many units is it below? It's 1, 2, 3. So the comparison, so the actual answer here, in addition to your graph, is g of x is, let's say, shifted 3 units down from f of x. I am looking for a sentence here, please. And we didn't have to graph it. I mean, I did in the directions because that's what I wanted. But on some of them, they're not going to always ask you to graph. And the way we figure out our comparison is we just look at the y-intercepts. So I could have done that to begin with. The y-intercepts of my functions were 0 and -3. I'm comparing how is my g compared to the f. Well, if it's a -3, that's 3 units below 0, which matches my graph. I can just look at the equations to start, and it gives me an idea of what the graph should look like. And that's also a little faster way, especially when I don't always tell you to graph. Like in this very last example. We're not going to graph these. We're given these two functions, g of x equals -x plus 5, and f of x equals -x. And I just want to compare. So how many units is g of x shifted compared to f of x? Well, I'm just going to rewrite them. So I know f of x equals -x, which is a fancy way to say y equals -x plus 0. And g of x equals -x plus 2. Again, this is a fancy way to say y equals -x plus 2. We're just going to look at our y-intercepts. So the y-intercepts on our original f of x is 0. The y-intercept on our g of x is plus 2. Well, it's a positive y-intercept here on the g, which means that it's above 0. So my comparison is going to say that g of x is how many units? Well, what's the y-intercept? It's positive 2. So my g of x is 2 units, or let me say is shifted. Let me go back and say is shifted 2 units up, because it's positive, from f of x. And if you don't believe me, you can graph this yourself and see that that's true. But that is it for your notes. Homework tonight is lesson 5.4, page 229 to 230, numbers 5 to 31 odd. You can either take a picture and write it down, but if there's time remaining in class, you need to work on this. Please remember that tomorrow you do have a homework check. Please check the homework check board to know what assignments, and I will see you guys tomorrow.